which is math. Last episode, I'd asked my other friend Adil the same question: math versus science. What's the difference? What's your preference? And what are your thoughts?
So, this is one of my favorite questions.
Okay, I'm so happy to be able to ask you that.
Yeah. I like to begin by defining something called formal systems.
Okay.
So, a formal system is any system in which you start from axioms. I'll introduce a bit of terminology here. Axiom means any truth, a statement which you take as a given. And then you define some relations or rules. And then you use those rules and relations on axioms to create theorems. That is, you interpret things from the axioms using those rules. So, math is the formal system. We start from very small things like those
basic operators.
Yeah, like basic operators, and that leads to the number theory. We start with basic things like all right angles are equal to each other, and two straight lines which are parallel never meet.
Okay.
And that ends up into geometry. So yeah, so math is the formal system, the largest formal system we've ever constructed. So there's also something called isomorphism. That is, if two formal systems have the same amount of information, they can be translated into each other. So, for example, I have a table and I have bananas. I take a banana, put it on the table, and put another banana on it. So I can also say the table is an operator of addition and the bananas are numbers. So I started with one banana, I put one more, and the table has now two bananas.
Okay, right. So the table has kind of facilitated the operation.
Yeah, so more than facilitated, it's taking the placeholder of addition. So addition represents the binding of two groups. So I had one group, I placed another group. So the table represents the whole set.
It's like a very intuitive way to think of operators.
Yeah, isomorphism.
Okay,
so that's basically one set of information. You are like these two systems contain the same amount of information. So I can say both of these systems are equal. If reality is a formal system, then science is about discovering the axioms, the truths, and the theorems. And math is the relations and regulations between those theorems and axioms.
Oh wow, that's very beautifully put.
Yeah, so like math is an isomorphism of reality if reality is a formal system. And science is used to discover theorems, and then we examine theorems and the axioms, and we say, how can these two things be related to each other? And we use math for that. So, yeah, so like it's not math versus science, it's always math and science, I think.
Right, so they don't do the same job, so there's no point in comparing them.
Yeah, unless you discover theorems, unless you discover axioms. For example, you can never discover the basic thing. Like you cannot discover the most fundamental truth of the universe, that things you assume using math. So, like in the quantum theory, you had to start with an idea that a particle can be both a wave and that thing, physical entity, and then start with relating those ideas to other previous ideas to come up with new ideas.
Okay. So, and that is where science does its work.
That is where science does its work. So,
and what are you more fascinated by?
See, so I previously said if reality is a formal system, then math is about the rules and regulations between relating the formal system, like binding the formal system together. If reality is not a formal system, then math is not sufficient. For example, I'll give you an example of a non-formal system, language. Ideas. Both of these systems, if you take the set of all ideas, so and the way ideas evolve, any system that evolves is a non-formal system. So,
is biology a non-formal system?
It's under debate. It can be pseudo-formal. So, it can be pseudo-informal. मतलब हमें ऐसा लग सकता है कि it's evolving, but it could be they're like really just a bunch of simple rules which regulate the whole process.
Okay, sorry, I had a tech issue. To continue.
No. So, as I was saying, language is a non-formal system. You can't mathematically predict what new phrases of words, like which new combinations of letters would become words next. How language, like how a bunch of different people, how a group of people will form their own slangs and terminologies. The evolution of language is unpredictable mathematically. It's just too chaotic. So Yeah, so there are non-formal systems. Reality has not shown many clues of being a non-formal system, but again, it can be one. So,
Okay, so in the case that it is a formal system, in that case, math, you would be more fascinated with math.
I would always be more. I am always more of a science person. But yes,
Okay.
in case it's a formal system, then once you figure out all the relations and regulations in the universe, and you know all the previous theorems, like, and you know a good amount of theorems, you can just simply derive mathematically all the theorems on your own. For example, black holes. We didn't know about them. We mathematically derived the idea of a black hole. So,
And it turned out to be accurate.
it turned out to be true. So, yes, reality does show a lot of signs of being a formal system. In that case, math reigns supreme.
Yeah.
Or math is the more useful of the two tools, science and math. But in case it's not, then math is redundant. It's simply another part of the evolving universe.
Wow. Okay. And right in this thing, where does